Hey guys, today we're going to do Unit 5, Lesson 5, and I'm going to break this lesson up into 3 different videos. The first video is going to focus only on the area model. This way, if you're struggling with any of these 3 different models of quadratic applications, that you can refer specifically to the video of the types of problems that you're struggling with. Okay, so let's begin to focus first on the area model. So the area model deals with area of rectangular figures. You'll be asked for the length, the width, or the area of the model sometimes after a change is made, if they want to increase the length or the width of a figure. Okay. You may be asked for a partial area or a combined area as well. So let's look at 3 different examples with the area model. So in this first one, we're looking specifically at a swimming pool company. They offer rectangular pool sizes with the dimensions as shown. Each pool includes a deck around it. So the first thing that we're going to do is write the equation to model the area of the pool. All right, so let's take a look at how we're going to do this. They show us right here, and let me zoom in some more. Okay, they show me that the length of the pool itself and width is 2x by x. And then on the outside, there is this 4-foot wide deck that goes all the way around. So if I want to know the total outside area, including these extra parts, I'm going to have to include an extra 4 feet here and an extra 4 feet here. Okay, so 4 plus 4 is 8. So what that's going to look like are 2x plus the 8 on the outsides. And then this will be, the length is, or width is x, and then you have to add the 4 and the 4 to the outsides of those. So x plus 8. Okay, and so that models the area of the pool where this is the length and width, but I need to go ahead and multiply this out to get the actual equation. So let's go ahead and do that. So the equation will be 2x times x is 2x squared. 2x times 8 is going to be 16x. 8 times x, and then 8 times 8. All right, and now let's go ahead and put these together and combine our like terms. 16 plus 8 is 24x. And so this is the final equation that represents total area of this pool. So now let's be a little more specific about what this particular customer wants. If Carolina wants a 15-foot wide pool with a deck, how many square feet will she need to have available in her yard? So what we're going to need to do is wherever I see an X, I'm going to need to substitute 15. Okay, she wants this to be 15 feet wide. So we are going to take this equation and substitute in 15 everywhere. All right, so let me go ahead and put in my 15. And so now we're ready to simplify this, all right? 15 squared is 225. 225 times 2 is 450. 24 times 15, let me just type this in my calculator, is 360, and then plus 64. So if I add all of that up, I get 872. So 450 plus 360 plus 64. No, I'm sorry, I get 874. 874 squared feet is what she will need to have available. Okay, and so that is working with an area model. Let's take a look at a second example of working with an area model. So I'm moving in my notes to example 4, if you have the guided notes. All right, example 4. The side lengths of a square can be represented by the expression x minus 2. The formula for the area of a square is area equals the side squared, where s is the side length. What is the equation that represents the area of the square? So let's go ahead and fill this in. Area equals x minus 2 squared. Okay. And now we can go ahead and multiply this out. And so x minus 2 squared is going to be x squared minus 4x plus 4. So all I did was multiply that out. You can use, again, either the distributive property method or the box method, but just be sure that what you're doing is x minus 2 and x minus 2 like that, okay? All right, now what if we have to make some adjustments to this? If the length is shortened by 1, so again, I used to have x minus 2 and x minus 2. Well, what if I shorten this by 1 more? So minus 1 in red there. And then this was also x minus 2. But what if I lengthen that by 4? Okay, lengthen by 4, shorten by 1. So that means plus 4 minus 1. Okay. What is the new area of the figure? So let's simplify this. Negative 2 plus 4 is x plus 2. Negative 2 minus 1 is x minus 3. And now we're going to go ahead and multiply this out to find the new area of, instead of a square, I now have a rectangle. So I'm going to get x squared minus 3x plus 2x minus 6. And then let's simplify these common terms in the middle. And this is my new area. It's my new area. All right. So we've done a pool, we've done basic squares and finding area as well as rectangles. Let's do one final example. Again, if you're with me in the guided notes, I'm moving on down to example 7. One edge of a painting is 6 inches longer than the shorter edge. The picture has a 2-inch wide frame. Okay. Which quadratic function represents the total area of the picture and the frame? So we've got some multiple choice here. So let's go ahead again and remember, this is x plus 6 right here, the white part. The blue part on this side is 2, and the blue part on this side is 2. So here's what I'm going to have for this total width here. It's going to be x plus 6 plus 2 plus 2, which is the same as x plus 10. Okay, now let's do it for this side. This is side length x plus 2 plus 2. So it's x plus 4. And so when I multiply this all out, I'm going to get x squared plus 4x plus 10x plus 40. Which will give me option D right here. Okay, so of my multiple choice options, that's my answer. Now let's do part B. Part B says, what is the total area of the framed picture if the shorter edge is 8 inches long? 8 inches long. Well, the shorter edge was x. So if we want that to equal 8, everywhere in this equation that we see an x, we want to substitute an 8, okay? So x squared plus 14, x plus 40. So I rewrote that over here, and I'm going to plug in an 8 everywhere there was an x. Okay, and so now let's go ahead and reduce all of this. I get 64 plus 14 times 8 is, where's my calculator? I don't know. 14 times 8 is 112 plus 40. And then if I add all of that together, I should get 216. So that is the answer that goes in the box, 216 inches squared. Okay, so those are our 3 examples that we're going to talk about today that deal with the area model of quadratics. Okay,